Hi everyone, my name is Paul Broysen. I'm a technical artist at SideEffects. I am also the lead for the Labs initiative. And today we're going to be talking about just pipeline things. So this training or presentation, if you will, is meant to be a high to medium level overview of all sort of different things that a lot of TDs have to worry about when they're dealing with pipeline work. So we'll see a wide variety of different things that we're going to be covering. I'll be pointing out some resources for you to look at online to follow up on some of the things that I'll be mentioning. So once again, this presentation really is meant for you as a starting point to do your own investigations and research with. All right, so to begin with, something that people always have to do, configuring an environment. So what we see here on the left is our good old Houdini.env file. And this file is what a lot of people use to basically configure some environment variables, to declare some new environment variables, to add some things to the Houdini path. So this is what people would often use to essentially, for example, install SideEffects Labs or QLib or any of the other packages that are out there. And that used to be the old way of doing things. I know a lot of studios are also, of course, using other software to manage all of these different things. But I wanted to point out the correct way of doing it because Houdini.env really shouldn't be used anymore. Houdini has a ton of environment variables built in that you can modify. So I would recommend checking out this website here, or sideeffects.com/doc/houdini/ref/env. Which shows you all of the environment variables that are known in Houdini, so that you can use those. So, for example, disabling the console, use the shell instead of the console, changing the verbosity of logging errors and warnings and such. So check that out for all the different environment variables. So I mentioned that this is the incorrect or bad way of doing it if you're modifying environment variables yourself. So what is the correct way of doing it? Well, as of Houdini 17.5, we now ship with something called packages. And packages are meant to be a sort of modular approach of configuring environments. So instead of putting everything in this Houdini.env file, you now can create a new folder in your in any directory that is part of Houdini path. In this case, I just used my documents one because it was on my local machine, and you can create packages there using JSON files. So what is this packages stuff all about? Well, the packages are essentially files that describe plugins. But it goes further than just plugins. You can have packages for studio variables, project variables, user variables, variables for each plugin. There are JSON files that describe all of this information, and it even allows small expression language to use for some automation. So, for example, do you want to load these files if it's Python 3 and these files if it's Python 2? Do you want to load this package based on if another package is present? So it allows for a more procedural and configurable way of configuring the environment. And most importantly, I put these big three arrows here in blue. This removes the need to edit Houdini.env. I know it is very easy to modify a file like this in a text editor and just use it as is, but really you should not be using this anymore. And I'm going to be showing you why packages is better. So, in the packages folder, how do we go about creating these packages or plugins? Well, like I said before, we can just create a folder called packages, and inside of there, we can create JSON files. So we can create one JSON file that contains everything, or we can create one JSON file per package, plugin, per project, per user that we want to be loading. So in this case, SideEffects Labs, my secret projects, Megascans plugin, machine learning, grooming environment. You might have all sorts of different types of things that you want to configure, and you should be using these JSON files. So my recommendation is just make one per plugin or project. So using packages files, what can we do with it and how does it work? So packages must be valid JSON, and they must have the JSON extension for Houdini to pick them up. Houdini will also scan all of these directories that are listed here to see if any packages file exists there, and it will load those and parse all of them to configure your environment. So the one that I used was just Houdini user pref there, which on Windows is just documents / the Houdini version / packages, but you can use HFS / packages, which is the Houdini install location, which I would not recommend. You have HSite, you have Houdini package there, which you can also, of course, configure. And then, like you see here, HSite must be set to an existing directory before starting Houdini. So that is something you do have to worry about when dealing with this in larger pipelines. Let's see. Yeah, it sorts them in the topmost directory first, and then it sorts them alphabetically by file name. So something to keep in mind if you want them to be loaded in a specific way. Make sure you keep that line in mind. You can have multiple package files in each package directory on the path that you see here. It will not scan subdirectories, so that is something to be aware of. And packages can be specified dynamically from a package file. So more about this on the documentation that you can find online. So let's take a look at how we can write the package files. So the package files have a couple of keywords that you can use that are built in that Houdini knows about. So the env keyword is basically allowing you to configure, modify, or add new environment variables that you want to be created in the session that you start up. So if, for example, you want to create an environment variable called SideEffects Labs, you'd create this env keyword and then just make a list where you put these in. So of course, you're going to need to learn a little bit about the JSON syntax, but it's not too scary once you understand it. And then enable is another really, really useful one. So let's say the simplest form of a package is this here, right? Where we have the path, and path is just Houdini path, right? So anything that you add in here is going to be added to the Houdini path. So if you just want to add some directory to be loaded, so it scans all of the OTLs or HDAs, desktop scripts or whatever else, this is the only thing you really have to do. It's 3 lines, right? You have these curly brackets opening, path, and then curly brackets close. Now, if you want to make it easy for you to enable and disable those whenever you load something, you can use the enable keyword. And all you really have to do is just add enable, then the colon here, and then true, and then a comma. And then it's going to be enabling this and loading it on load. If you want to disable it, you don't need to delete the package file. You don't need to comment out anything. You just change enable to true, to false, sorry. So let's make it a little bit more complex. So in this case, we want to be defining SideEffects Labs. So this is how we do it in the SideEffects Labs package. We configure a new environment variable called SideEffects Labs. We set it to a path. And then we just tell it that path is equal to that environment variable. So this makes it a lot easier for us to reference SideEffects Labs anywhere in Houdini and any of our tools and such, which is all going to be pointing to this one path. So we only have to type it once there. Load package once is really useful if you have package files that are placed in multiple locations, which might accidentally load packages multiple times. So let's say you have 2 versions of SideEffects Labs installed. You have one that lives in the Houdini install, and you have one that lives in documents. It would load or try and load both of those, but if you use the load package once keyword, it's only going to load that once. Recommends and requires are other 2 really powerful keywords, which allow you to, first of all, have Houdini print out a message that says, they recommend also loading this package in case you don't have that loaded. And it also allows you to specify packages that need to be installed for another package to be loaded. So let's say you have 2 packages, one that has grooming tools, and you have a package that has grooming tools that has Python states in it. Of course, if you were to only load the Python states grooming toolset, it wouldn't work, right? Because it needs those grooming tools that you have. So with this requires keyword, you're able to create those kind of dependencies for it to load properly. So I also mentioned expressions. So we're going to see some more expressions and what we can do with them on the next slide, but I have two simple examples here. We have enable, depending whether or not our platform is Windows. So instead of just typing enable true, we can enable this package or disable a package automatically based on our platform. So if we're using Windows, it's going to say true. If it's going to be Linux, it's going to say false and therefore not load the package. Then further on, we have another couple of examples here where we're going to be using the Houdini version to decide what we're going to load. So if the Houdini version is 18.5, it's just going to load SideFX Labs. If the version is 18.5.400, load this very specific version of SideFX Labs. If the Houdini version is equal 18.5.500, it's going to load this other very specific version of SideFX Labs. So if you're creating packages and tools that require a very specific version of Houdini, this would allow you to dynamically decide which package you're going to load for this session. So continuing with the expressions, what else can we do with it? Well, we can use the following operators. We can have these round brackets, which establish the precedence. We can do equal, we can do not equal, we can do smaller, larger, smaller or equal, larger or equal, and an or. So with all of these, we can do some fairly interesting and complex expressions to load or not load packages. We can compare with a literal string by enclosing the string in single quote. So that's what we saw on the previous slide as well, where we have Houdini OS equals Windows. As you can see, Windows is between the single quotes. We can use environment variables in a comparison by prefixing the variable name with a $S. So that's what we saw here, right? We have the $sign SideFX Labs. And we can use Houdini version and Houdini OS, which is what we saw before. And then one that got added literally yesterday is Python version. The expression language supports string values only. So if you want to do numbers right now, you're going to have to use strings like this. But as you can see, that does work with something like Houdini version. So a couple of examples. We have Houdini version equals 16.5. Houdini version equals 16.5, and the OS is Linux, so this is already more complex. We can check if the Houdini version is between a specific version. So in this case, if it is larger or equal to Houdini 16.5 and smaller than 17.5, so this means that this package will only be loaded in 16.5 or 17. We can check if the OS is not equals Windows, or if the Houdini version is 17.5, or the Houdini version is equal to a specific version. And then, of course, here we have something even more complex, but it is something that I'll let you take a look at in your own time. If you want to know more about configuring environments using plugins, you can go to this website here in our docs/Houdini/ref/plugins. All right, so now that we know how to define a package and we know how to configure environment variables, modify them, set them, update them, let's talk a little bit about packages themselves. So what are packages? Well, packages have been out there for a really long time. It's no new concept. There's many toolsets out there that are essentially what a package is, right? We have QLib, we have SideFX Labs, we have mops, we have OD tools. There's many more out there that I would recommend taking a look at. But all that it really is just a bunch of directories, a bunch of files that use a specific name, use specific folder names, so that Houdini understands them. So the most commonly used one, of course, is the OTLs folder, which is where we store all of our HDAs in. So if you want to have HDAs and deploy them to a user, very simple toolset folder structure would be just having an OTLs folder, and then that's it. So in SideFX Labs, as you can see, we have a ton of stuff in here because we were touching many different parts of Houdini. And the awesome thing is that Houdini is extremely customizable, which is why a lot of studios like working with it. So as you can see, we have, for example, the Paint tab type menu, OP menu, which is just the right-click menu when you click on a node, Op Customize, which is, for example, allowing you to hide or create aliases for nodes. We can do the network view menu so that we can add or modify some menus. We can do the main menu common, which is the top bar in Houdini. And then not stopping with that, we also, of course, have HIP, which allows you to create example files, OTLs, which I mentioned before, Python panels, if you want to create Python panels, scripts to store all of your Python and Vex in, toolbar, Vex, and viewer states, which allows you to store all of the Python states. So what we're doing with SideFX Labs is uploading all of that stuff to GitHub, because most of these are text files, which allows us to diff those very easily and see all of the different alterations that we're making to those tools and files. So how do we know how to configure these files and what they need to be called? Well, that's the most interesting part of it, is that this is an exact copy of the folder structure that Houdini has itself. So if you look at the Houdini folder of any install that we have, you see all of these folders and files, of which some you saw in the package that we created. Well, that's because packages are configured and ordered the exact same way that Houdini is. So if you're not sure about where to, for example, put radial menus, I would recommend just going to the install location of Houdini and look for what it is you're trying to configure or modify. And that's just going to show you how to do it and where to do it. So it's a really useful example to use as a starting point. Next up, the Houdini launcher. The Houdini launcher is an extremely efficient way of installing and managing Houdini and all of the different plugins. So what you can do is you can go to the SideFX website and download the launcher, and that's going to allow you to update Houdini, install new builds, install the license manager, install engine plugins from within a single application. You don't have to go back to our website and update and download new builds there. You can do all of that from within the launcher. It even allows you to sort based on versions, the release type, the build type, and the coolest thing about the launcher is that it only really updates deltas. And what I mean by that is, let's say you have this version of Houdini installed, and then 2 days later you're going to install this version. If you were to use the old installer of Houdini, it would have to download the entire data that belongs to this version of Houdini. The launcher does it more intelligently. Since you have an older version of Houdini, it's going to check what the differences are between these two versions of Houdini and only download the differences. So if, let's say, the only thing that has changed between these two versions is some sort of example geometry or test geometry, then it's only going to download the test geometry and then copy the rest of the other version of Houdini into the new version of Houdini. So it makes it extremely fast and efficient to download. You can also, of course, uninstall things. You can install engine plugins. So if, let's say, you want to install the Unreal, Unity, Maya, or 3ds Max plugin, all you really need to do is just go to the engine plugins tab here, select the version that you want to install it for, select which plugins you want to install, and then just hit OK. You can install any of the plugins. So in this case, the only one right there is SideFX Labs in this case, but we'll be adding more in the future. You can also access the license administrator, of course, and a lot more. So you can decide what version of the launcher you want. Do you want to use the beta builds of the launcher? Do you want to use the production builds, the daily builds? You can configure default install options. So, do you want to install the 3ds Max plugin by default as soon as you install Houdini? You just add that here in your preferences and it's going to do that for you. Do you want to automatically install the license server or SideFX Labs? Start menu, file associations, all of the stuff that usually you would have to, click through and select in that old installer, you no longer have to do with the new installer. For more information, visit this link that you see here. And of course, the question that is always going to get asked with the launcher is, well, a lot of people use automated scripts to download all of their updated Houdini versions and such. I cannot do that with the launcher. Well, you can. We've also added all of the command line scripting capabilities that the old installer had to the new launcher. So the script that you see here is a script that I got from the documentation page of the launcher website. So just go there if you want to read the specifics on it. But it has a lot of convenient helper functions, such as getting the current platform, create a server, You can download a build. If you have a specific build number in mind that you want to get installed, you just run this function here. It's going to give you that. It's going to download files from you, make the executables. So it handles not only the finding out which new builds are available, it gets a list of those, it downloads them, but it also installs them for you. So here is the part that you're probably going to be most interested in. It's just this run function where you can specify the product. And the product essentially tells you what is it you want to download. Do you want to download Houdini? Do you want to download the launcher? Do you want to download the license manager? Do you want to download Maya? Do you want to download SideFX Labs? And then everything else it just does for you, figuring out the platform, creating a service. So the only thing you really need to worry about is this product and making sure that you have a client ID and a client secret, which would be your SideFX email that you have on the forum and your client secret, which would be your password. We have a SideFX web API that allows you to use preference files instead of having to just encode your password in this Python file. So go check that out. So what can you install with the launcher? With the script, apologies. The launcher itself, Houdini, Labs, or any other plugin. The Houdini engine plugins, the license server, HQ, client, and server. And you can update Houdini and the other plugins. You can repair Houdini. You could uninstall Houdini, although I wouldn't know why you would ever want to do that. And it is now the recommended way of downloading and managing Houdini. Next up, Python libraries. We all know that we're often doing stuff in Python and Houdini that requires external Python libraries. For example, SciPy, for example, PyTorch, and of course Houdini doesn't ship with those. So how do we get those installed into Houdini? Hi everyone, today I'm going to show you how to install external Python modules that Houdini does not ship with. For example, SciPy. In this case, as you can see, I just drop down a Python node and try and do import SciPy, and you'll see that it's going to throw an error called no module called SciPy. So how do I install an external module into Houdini the easy way without using Houdini Python path? So what you can do is you can just go to the window drop-down menu and click on shell, which will open the shell, where I'd like you to just copy the line that I just typed there, and then all the way at the end, modify it so that it points to some path on your disk. So in this case for me, I just decided it will be on the D drive in a folder called example. Once it's done that, you can see that we now have that getpip.py file in that folder that we specified. So the next step is to install it into Houdini. So what we do is we type Python, that is with an H, which means essentially the non-graphical version of Houdini, and then the path to the file on disk where we downloaded getpip.py to. This might take a little bit depending on your internet speed, but once it's done, it'll tell you that it either successfully installed pip to Houdini or it did not. In this case for me it did, so let's just try and import or install SciPy in this case. So next up, on the next line, what I'd like you to do is once again type Python with an H once again, -m, and then pip install, and then a name of the module you'd like to install. So in this case, once again for me, that is SciPy, but you could install anything you'd like. For example, TensorFlow, PyTorch, or any other cool module that Houdini does not ship with. Once you've done that and you hit enter, you can see that it's going to be downloading that module. In this case, SciPy is quite the beefy package. It's about 33 megabytes, as you can see. So in this case, because I have poor internet, it takes a little bit for me to download this. Once it is done, it says installing SciPy. And then once that is done, you should now have SciPy installed. Before you do that, make sure you open up a new copy of Houdini and then just drop down that Python node and type import SciPy. Once that's done, you can see that it's successfully imported and installed SciPy into Houdini. The other cool thing about this approach is that the installing of pip that we did at the beginning is something you only need to do once on your machine. So once that's done and you've got pip installed already and you want to install some other module, all you really just have to do is just type Python -m pip install and then the name of the module. So for example, SciPy in my example, but you could use TensorFlow or anything else. So this is the only line that you have to run if pip is already installed into Houdini. All right, so that was a quick video showing that this approach has a couple of upsides, has a couple of downsides. What I'll mention is that this approach will install pip and those modules to a specific build of Houdini. So if you want to install something that is more global, right, that persists throughout multiple versions of Houdini, I would recommend using the second method, which is this one, and that is configuring a Python_path environment variable on your machine. So how do you do that on Windows? Well, you just type, press the Windows key, you then type environment variables, and you're gonna just hit that first option. It's gonna pop up this system properties window, where if you go to the advanced tab, you can click on this button that says environment variables. And once you click that, this window is gonna pop up, where you either already have a Python path environment variable, but in case you do not have it, which is what I had, you just click new. It's going to pop up this window here, where the variable name is going to be called Python_path, just like that. And then you're going to point to the directory where you have Python installed on your machine, and then point it to the /lib/site packages, which is the directory where pip would install all of the libraries that you would be installing on your machine. So TensorFlow, PyTorch, SciPy, whatever it is you want to do in Python. So once again, the previous approach that I showed you is useful if you just want to do some quick experimenting and testing. If you want something that is more persistent throughout multiple versions of Houdini, this is the way to do it. Next up, more pipeline stuff. So startup scripts. Oftentimes when you're dealing with pipeline work, you have to configure Houdini environments, Houdini setups, depending on who is using Houdini and what it is you're going to do. So let's say you have a couple of surfacing artists that are going to create some materials, and you want to make sure that they always work in the same exact lighting situations and the same sort of background. What you could do is you could create a startup script that is going to initialize Houdini in a specific way. So in this case, with a ground plane and 2 lights and a network box around that with a comment in it. It's of course a bad example, but you get the point. So how do you do that? Well, Houdini has 2 scripts that it knows about when dealing with startup scripts. We have the 123.py file, and Houdini is going to run that script when Houdini is started without a scene. So let's say you have the launcher open and you click, open Houdini. It is then going to run 123. If you have, a shortcut on your desktop and you double click it, Houdini is going to run 123.py. If, however, you have Houdini open already and you do file new, it is going to run 456.py because it, like the documentation says, Houdini runs this script whenever a scene file is loaded. So once again, 123, just like it sounds like, that's the very first thing it's going to do. And then 456 is something that comes afterwards, after Houdini has already started up. You put these files anywhere in the Houdini path. So in this case, for me, it was just in documents /Houdini 18.5 /scripts, and then 123. And then the next time you boot up Houdini, it's going to recognize that script and run it for you. So that example that we saw on the previous slide with the lights and the ground plane, that's just this very simple script that I created that I put in the 123.py script that we saw. So we just create a geometry node, we create 2 lights, we set the parameters of the lights, and then we just do some scene organization by creating a network box, adding the nodes to the network box, moving the nodes to a good position, and setting a comment. For more information, once again, check out this documentation page, the home documentation /locations, and then the startup scripts section for this information. So here's the interesting part that we've all been dreading. The VFX reference platform specifies that in 2021, the Python versions that should be used in the large DCCs and other software should be 3.7.x. As you can see, in 2019, this was 2.7.9. And Houdini has been shipping with a tech preview of Python 3.7, so we are fully compliant with this VFX reference platform. But in the next version of Houdini, this is going to be the default. And the TDs that are watching this know what that means for them, which is why they've been dreading it. All of your Python that you're running in Houdini should be compatible with Python 3.7. So you might be thinking, well, that's a lot of work, and I don't really look forward to it, which is something you might be thinking, but Houdini actually ships with a convenient utility that helps you convert your Python code. We ship a Python script called py23convert, and you can find it in any of the Houdini install directories. If you go to the install directory of Houdini and then /bin, you see this Python script that says py23convert. And what that allows you to do is it allows you to, for example, run a py23convert and then foo.py or whatever your Python script is, and it is to convert that script for you from Python 2 to Python 3. This information that you see here can also be found in the docs when you run py23convert and then do 2 dashes and help, which is going to show you all of the command line option for this utility. So once again, if you have a lot of Python 2 code that you still need to convert to Python 3, this is the way to do it. As you can see, it can run against a single Python file, a folder containing Python files, an HDA file or an expanded HDA directory. It can convert Python modules and on event sections in HDAs. The only thing it doesn't do currently is Python parameter expressions embedded in dialog script. So really, this is the good way of doing it if you don't have any other automated way of converting things from Python 2 to 3, because this handles scripts, it handles Python modules, it handles HDAs. So, check it out and give it a try and let us know how it goes for you. We've been using this ourselves and it's been very successful. Moving on. Talking about utilities that we have in Houdini in terms of convenience functions and whatever else. Houdini also ships with a large amount of standalone utilities. So, Houdini is the application that we all love and use, but it also ships a lot of standalone utilities that we often use in labs tools, for example. And these can all be found in the bin directory of Houdini, similar to the py23convert. And so what do we have in there? Well, a lot of those are programs that are useful for batch processing scripts. So let's take a look at a couple of them. We have GeoDiff, which displays geometry differences. So this is useful if you, for example, have 2 BGOs living on disk, and you want to know what the differences are between those two. You can either load this up into Houdini individually with file sops and then open the geometry spreadsheet and check out what the differences are, or you can use GeoDiff to have it tell you what the differences are. It can tell you there's differences in point counts, and these are the specific point numbers that are different. It can find differences in attribute values. It can find differences in primitives and a whole lot of other stuff. Similarly to geometry, we also ship iDiff, which, like the I might imply, display image differences. So if you have a pair of images and you want to know if they're equal or how equal they are, you can use this utility, which is going to tell you how many pixels are equal. You can tell them, you can have it use a tolerance to specify when something should be considered different or similar. And it will also tell you which pixels are different. iConvert, which converts image formats. So in this case, you just use iConvert and then the 2 images that you have, the optional arguments, and it's going to convert images from one format to the other. So something that I often used to do in the past is, for example, converting JPEGs to EXRs or EXRs to JPEG. And what I used to do is I used to load those up into COPs and then just save them out in a different format. That is a lot slower than using iConvert. And so by using Python and the shell and running iConvert, it happens in a matter of seconds instead of a lot longer in COPs. So check out these utilities. There are a ton more. So just check those out by going to the docs/Houdini/ref/utils. which has an overview of all of them that we have in there. So now that we've seen a couple of those utilities, I wanted to show you what you could, for example, do with it. So we all know that Houdini has tops, and tops is really useful for managing and processing a large set of files. So an example, we can use the file pattern top to load files on disk with, for example, a specific extension or from a specific folder. We can then remove some files. We can then do some processing on that geometry. And then we can diff those, right? We could check whether or not two files are different. So in this case, this validate assets HDA, all it really does is check if specific attribute values exist on my geometry. So if I have specific requirements for my geometry, like it needs to have a UV and a UV2 channel for my game engine, then we can have it check for that. If it needs to have vertex colors, we could also specify that. And then the output of a node like that would give us something like this, which is a regression test log. We'll see more about regression tests later on, but in the previous example that I used, in this case, it would tell us that the vertex colors and alpha are missing. So this would allow us to run through a really large library of geometry data and tell us what the problems are with those files. Project management. So now that we've looked at configuring projects and HDAs, creating packages, we of course create content in Houdini. Creating content in Houdini, produces and depends on a lot of external files that we either create or load. For example, saving out geometry that we're going to render, textures that we're going to render or have created that we've either gotten from the internet or from someone else. And so if we want to send something to a farm, it's often very difficult to know what all the dependencies are for our scene file. All the textures that we need, are they in our job structure? Are they all next to our hip file? Are all of the path relative references instead of absolute references that do not exist on the farm? Well, instead of trying to figure all that stuff out ourselves, we can use this labs archive project top. And what this allows us to do is it allows us to run this node in the top network and find all of those dependencies for us. And it's going to create a convenient zip file and a JSON file describing all of the environment that we've used to get the result that we see in our viewport. Additionally, it's going to create a copy of the currently open hip file with all of the absolute references that it has found replaced with relative references to all of the files that it's made a copy of. So this makes it very easy for us to just take a hip file that we've used and loaded external files in, run this script, it gives us back a zip file, and we can just send that zip file to someone, they can open it, and they will have all of the dependencies nicely present and all of the parameters referring to those files all neatly working. So like I said, it also makes a copy of your environment. So let's say you want to know exactly what files were used and where they were used. So in this case, we have this polyreduced geometry that is being used in a specific node and what the source path was. It can create this JSON file describing all of that so that if later on we want to sort of backtrack what we've been doing, we can use that JSON for that. Additionally, if we have been using certain environment variables, for example, for ACES workflow, or did you set that to be a specific configuration? That is something you can also configure here, so that later on you can figure out why does this render look different from this one. That is because I had this environment set. So this allows you to load up those environment variables and configure those using the packages system that we saw earlier on. So now that we've seen a lot about content creation, another thing that I'd like to point out is this new thing that we have in SideFX Labs, which will also be part of Houdini 19 by default, is this thing called VHDA, or Version Digital Assets. And it's essentially just a wrapper around all of the HOM capabilities that Houdini has for creating and versioning HDAs that we've just simplified into a nice interface and a bunch of helper functions in a Python script that you could call for yourself. So what does it do? It really just creates HDAs with specific names and types, and makes it easy to set the label, the tab menu, the versions, managing namespaces, where you want to save it, preferences and such, and made it into this interface. So let's take a look at what you can do with it. You can, for example, have an HDA that you've been working on and you want to create a new version of it. All that you really just do is select your HDA, make the changes that you want to do to it, right click on it, and then hit save. So in this case, we just save it as a new type of HDA. And so let's say we want to make some changes to it. So in this case, instead of doing the previous output that the tool had, we're just going to swap it with a box as an output, as to make it really, really clear that something different is happening. So we want to make a new version of it. So we just right click, we save version digital asset, and hit major version update, right? So now we've bumped the major version of the tool, just like that. So the tool also allows for setting preferences. So if, for example, you want to always save HDAs in a specific location, you can configure that. If you want to use custom user namespace or custom branch namespaces, you can do that. If you want the menu entry and the tab menu to be a specific something at all times, you can set that here, and a lot more. So why am I pointing it out in this pipeline talk? Well, like I said, it's all Python based, and we have this Python script in the labs install directory in the python/labs.py folder. Here is it on GitHub, if that's easier for you to take a look at it. And if you dive inside of there, you'll see that it is quite a large script, but it has a lot of really convenient functions to do all of the different stuff that I was showing before using the interface. So if you want to create a new VHDA from subnet, you can call this function and it will just do that for you. If you want to increase the major version of a node, you can just call this function. If you want to copy it to a new VHDA, you can just call that function. So even though that we have our own interface with, the specific way of doing the branches and the user namespace and versioning, that is something that we have decided on. If you want to do it yourself in a different way, in terms of creating the file name, the versioning, the namespace and such, you can very easily just call all of these utility functions that you find in that Python script and just configure it your own way. Another set of useful ones that you can call is the separate VHDA type name components. So if you give it a full node name, right, with the user, the branch, the tool name, and the version, this is very easily going to give you back all of those separated components for you. If you want to just open up that interface that we saw before with presets that you have in your studio, you can also just call these new VHDA window or new VHDA bump version window, allowing you to do all of that stuff that we did in that interface by yourself using just Python. So enough about VHDAs and HDAs in general. Now that you've created a ton of HDAs and HIP files, how do you make sure that all of the stuff that you create works and stays working when you update versions or switch Houdini versions and stuff like that? Well, you can use something called regression tests. And regression tests are essentially just automated ways of testing either HDAs, HIP files, comparing data. So, a couple of slides back, we saw those utility functions that have geometry diff and image diff and text diff. This is essentially a network that we've built that encapsulates all of those different utility functions, allowing us to very efficiently and quickly test all of these HDFX Labs tools every single time we make a change to a tool. So if, for example, we fix a bug and we accidentally introduce another bug, the intention is for this setup to automatically catch those mistakes and let us know that we've broken something that was previously working. And so to find these files that I'm going to be showing you, you can go to our GitHub, and then in the automation folder, we have two, one called smoke test and one called unit test. I'm going to be showing you the unit test, which is essentially just testing the output of all of the different HDAs. Smoke test is something you can look at as well, but that's pure Python, which essentially just drops down nodes and makes sure that they all have the correct namespace, the correct tab menu, for it to adhere to the rules that we've set up for the SideFX Labs toolset. The HIP file that we're going to be looking at is this pdg_unittest.hip. So the HIP file for the regression test consists out of 4 major sections. In the first section, we're going to be loading all of the tests. We're going to be looking at what a test looks like in a little bit. Next up, we're going to be generating the diff data. So we, of course, need to know what is correct in terms of the output of a tool and what is the actual output of a tool. And then we're going to need to do some diffing on those, which is what happens in the next step. So we're going to check if the previous output that a tool generated that is correct, that we've manually verified, is equal to what the tool is currently outputting. So after we've done our bug fix, is a tool still doing the exact same thing that it was doing before? If not, we need to check out why it does that. Perhaps it is indeed now the correct expected output. And then after we've done all of our tests here above, we're going to, of course, generate a report, because we need to tell the developer of the tool that they've either messed something up or that everything is as good as it can get and everything is all smooth. So with the regression tests in labs, we have 2 main tests that we are running. We are running geometry tests, which is, for example, checking outputs of a node. So this doesn't mean that these nodes are generating geometry saved to disk. This just means that it is generating some sort of geometry or volume that you can see in the viewport. We can enable or disable a test. We have a description of the test so that we know what it is running. We can specify what the file is for the test. In our case, these are always HIP files because we're dealing with Houdini. And then an output, which describes what is the node that we want to test. We can also optionally specify a frame range. So if we're dealing with nodes that are doing animations or anything else like that that is time dependent, we can also specify which frames the tool has to be tested at. We can also do ROP tests. So these are for nodes that save something to disk or that are cop nets. And once again, we can do the disabling of the test, the description, the file, the output, but we can also specify the output file parm, right? Which parameter describes where something gets saved to disk. We can also specify the output file parm pattern, which means, what is the name of the file that we're going to be exporting, the button that optionally needs to be pressed for it to be executed, and then once again, the frame range. So as you can see, this is just a JSON file that describes all of these different tests, right? Every single block that you see here is one test. Every single one is for a single tool or multiple tests for a single tool. So in PDG, we have these convenient JSON nodes, and these JSON nodes are just going to load up those JSON files that we saw before. And what it's doing is just we have one node per type of test, one for the geometry nodes and one for the ROP nodes. And then we're going to get all of these work items, one for each test. So I've selected one of those work items, and we can see in this case, this is a test for the gas flame front node that we have. We have the directory, we have the file that needs to be loaded, the file name, the Houdini version, the output node that we need to check, the type of test, who made this test, and the frame ranges. Once we have that, the network keeps cooking. It does a bunch of attribute wrangling here. And then we have this Python script. And the most important part of this Python script here is that it is going to spin up a Python session. Python is essentially just a copy of Houdini that runs without the graphical interface. So it's a Houdini version it's a Python version of Houdini. And so what we do is we just load a HIP file in that Python session, and we're going to be running those tests, right? We're going to save out the node at the specific frame ranges that we've set, and then just save those to disk so that we have some geometry or data to test with. So now that we have that scene and we've saved everything to disk for that test, we need to do our diffing. We have our primary input and we have our secondary input. The primary input is some sort of file, a baseline file that we've saved on disk before, that we've done manually, right? This is our gold standard. And then we have a second output file, which is the file that the Python process that we saw earlier saved out. And the hope is that these two are identical. If they're not identical, then we know that something has changed in either how the tool works or in Houdini itself, and we need to go check it out to make sure that our tool still works. And so we can use this convenient labs node that we have in TOPS called data diff. And all it takes is two input files like that, and it's going to tell us what the differences are in the files in this diff log parameter here, or attribute. In this case, it is empty because these two files are identical, which is what we'd like. And then the last thing in our network that we saw is generating a report file. So this report file is just going to take all of those log files that we saw earlier and just concatenate them into a single text file so that we can email that to ourselves and let us know if something is broken. So with the labs workflow, are we running this network every single time by hand whenever we change something? No, we've configured this with a Jenkins instance on the internet. And we run this PDG network from Python itself. So what we do is we just load this hip file, which is that PDG_unit test. We find the top node that we want to be executing. And then we tell PDG, cook every single work item that you can generate. We then find that the text file that contains the log that we've generated at the end. And then we just print out that log, which then gets sent to us by email. And that's it. That's a regression test. It's really convenient for automatically testing hundreds or thousands of HIP files, HDAs, or anything else that you want to diff on your computer. So that's it. This is the end of this talk or training. If you have any questions or if you have any thoughts or think that we missed anything, please let us know. We'd also be happy to help you out with side effect support. So just email us at support@sideeffects.com. Thank you for listening, and I hope this was useful for you. Have a good day.